So this next part is on vGPU sizing. This is a topic that many people, not just in Japan, but throughout APAC or throughout the world, they want to know, I've got an application, but how many of those applications can I put on a single GPU? So that's a really important point. But first, we need to consider some important factors before we start looking about how to analyze it. So first, we have to understand the difference between server rendered frames per second and remotely delivered frames per second. We also need to define the excuse me, I'm on the wrong slide. I'm going to go back. So understanding the existing non-slide VDI environment and the workloads. So this is what's running on your computer before VDI. So before moving to VDI, you're looking at, I'm running Dassault CATIA on a workstation. And you need to understand what workstation model that is, what CPU, how fast it is, the memory size, and what type of storage it has. Also, to assist with GPU sizing, you need to understand what GPU they're using, or your customer or you yourself are using. And then how was that GPU selected for the workstation? Sometimes companies buy workstations pre-configured with a GPU, and the users don't know if they have too much power or not enough. Also, the applications that are used on the workstation, whether it's a Siemens NX or AutoCAD or CATIA, SolidWorks. Also, how many displays are required? Is it one display? Is it 2, 3, 4? And if you have any special input devices like tablets. Then you need to understand how to capture the system and GPU performance and then review that with users. So this will provide a data-driven recommendation so you can gain acceptance for moving to VDI or doing a POC. It will also allow you to segment the user requirements and size appropriately. So I already talked about this halfway, so I'm just going to go quickly through this. It's my computer problem. So, as I said, server rendered frames per second versus delivered. And the next part was to define the network per user network bandwidth requirements. So typically, most workstation users, they say, on my workstation, I get 60 frames per second, and I need that in VDI. So from an IT perspective, they need to deliver the network bandwidth twice as what required for 30 frames per second to deliver 60 frames per second. So when you're thinking about sizing, you need to start with a less dense vGPU profile and then assess the user performance. Then increase the density until the performance doesn't meet the user requirements. Don't start with the most density and then make it less dense. You should start with the least density and then make it more dense until the performance doesn't meet the acceptance testing. So this last part is fairly critical. This is not the last slide. This is the last part of this slide. You need to have acceptable acceptance testing that uses real workloads, not benchmarks. And I'll show a little bit later what I mean, the difference between that is. So you're going to need to log and monitor GPU utilization on the host and agree to the metrics. So you can define if this is achieved, then the POC is a success. And you can move towards doing a trial or deployment. Okay, who here is familiar with perfmon, the tool perfmon? Raise your hand. Okay, all right, great, okay. Who likes perfmon? Okay, one person does not like it. I like it. I mean, there might be better tools on the market, but everyone, basically, if you have a Windows OS, you have perfmon available. So because of the easy accessibility of this tool and its ability to capture metrics from the OS, it's easy to use this to capture the CPU, memory, and storage requirements of an application running on a workstation. This is pre-VDI. You also can capture using the NVIDIA WMI counters. You can capture GPU rendering and frame buffer utilization to determine the requirements for the application. So if you want to do an evaluation not on a workstation, but on a VDI instance, if you use GPU pass-through, you have the full range of GPU metrics available in the virtual machine. Whereas with vGPU, those metrics are not all available. So a minimum, there's lots of counters that you can monitor, and I typically capture quite a lot of metrics when I'm doing an analysis of an application. But these should be the absolute minimum, and these are just the metrics that I'll show in examples when I'm doing application categorization. These include the system memory, that would be available megabytes, the processor percentage, processor time being used, and then the NVIDIA GPU WMI counters, percent GPU usage, total frame buffer memory, and available frame buffer memory. Okay, so this is more the interesting part. This is a long video. Let me see how much time I have. I have 2 hours left. Okay. That's not a joke. Okay, one person laughed. Arigatou gozaimasu. Okay, so let's see. Can we see this? Or is it playing? Okay, now it's working. So here I have all these little windows open. I have, of course, a task manager there that I can see the processors moving. Then I also have perfmon running over here, and I'm actually looking at several counters. At the same time, I'm also logging a larger range of counters. So what I'm doing here is not a benchmark. Look, I can make it move without touching it. No, this is a video. So I'm performing some sketch operations to create a simple object in CATIA. And I'm talking too fast. Okay. So what I want to show is that when you're actually doing these typical user operations, the GPU requirements are very low. The CPU requirements are very low. This is a very simple model, but this is the type of operations you need to do when analyzing an application to categorize its requirements for GPU, CPU, memory, and frame buffer. So this video will go on, continue for me to do the modeling. And I'm going to skip ahead if I can. I'm trying to find the video control part here. Oh well, it didn't work. So here's just a screen capture of perfmon. This is a capture of the log file. And then I've eliminated a lot of the data points to just show several of these. So the top, I guess, what color is that there? Dark blue line is the GPU frame buffer total memory. So I captured this on a K5000, which has 4 gigabytes of frame buffer. So you can see that the line is approximately 4 gigabytes. And then the line underneath that is the available frame buffer memory. So while doing these operations, you can see the frame buffer consumption is very low. Next, the green line is the GPU utilization. Now, you can see that the average GPU utilization is well below, I'd say, 15% continuously throughout all the modeling operations. And also the CPU utilization is very low. Now, since everyone has used perfmon, and you look at the total CPU utilization number, this is going to be lower and lower depending on how many cores you have. So in the case of this machine, it was a hyper-threaded quad-core Xeon E5. So if it went to 20%, that would mean that one entire CPU was being consumed, or one process. Okay, so with this type of modeling operation, we can easily assume that 1 gig of frame buffer is more than enough. And even looking at the CPU utilization, the GPU utilization, it's never extremely stressed. So it would be very easy to recommend 4 users per GPU for the case of K1 or K2, or 8 users per GPU with the M60 or M6. Okay, so this was on a K5000, and depending on which GPU the customer or you are using, the GPU utilization will be different based on the number of CUDA cores and how fast that GPU is. So I attempted to replicate the same operations using the same workstation, but then with a K600. So you can see that the overall GPU utilization has now, on average, increased to about 20%, and then it spikes up to, wow, it spikes almost to 85% at one point in the modeling operation. So when you're attempting to analyze how much GPU resource you have to understand what range of GPU you actually have in the workstation. So right now I'm working on a white paper that talks about how to do the analysis and how to make a comparison table. And last 10 minutes of this conversation will be also about monitoring. So so let me just go to this next one. So not everyone uses CATIA, and so this one is Siemens NX, same workstation this time with a K5000, and doing some modeling operations. Whoops. And what happened? Okay, it's opening. Sorry, my computer is now, I have to look at this screen. So here I am paused. Looks like I'm paused. So let me skip ahead here a little bit. So here I am again doing the same sort of modeling operation. And you can see over here in the green, that would be the GPU utilization that's being consumed right there. And so I'm trying to create the same sort of part, but this time with Siemens NX, just to get an idea of the differences that the GPU rendering requirements are. So typically this is not the type of models that engineering customers would be doing all day, unless they just came out of college and were learning how to use the application. Let me skip this way. So now I've actually stopped that sketch operation, and now I'm actually loading this model right here. And it will take a long time, and luckily, thanks to the magic of time acceleration, we can continue. And you can see while it's loading that in red, this is the CPU utilization, that the application is using multiple CPU cores to actually load. And I'm going to speed it up a little bit more because we only have 7 minutes left. Okay, so here we are, we've loaded this full assembly and we're rotating it around. And you can see the frame rate is not terribly great, but the GPU utilization is also not maximized. So if you look here, the CPU utilization is about 20%. So we're getting close to that one. If the application was highly single-threaded for rendering, once it gets to about that range, that means that it can't process enough of the internal geometry data to call the API to render fast enough. So now we're switching views because typically users do not operate in the full assembly view. So we've hidden some of the other parts, and now we're going to try to perform some operations on those models. So the users would orient within the drawing to try to find the part that they're going to use, either visually, or typically they'll use the model tree, which exists on most CAD applications, to quickly access the parts and assemblies. And you can see throughout this that the GPU utilization is not going very high, and that the CPU utilization is still about 15 to 20%. Okay, so I'm just going to continue doing these operations, but I'm going to continue because we don't have much time. So here with the K5000, here is a result of all those operations. The first part was me doing sketching, trying to create a part, and you can see there's a spike at one point. And then after closing that, this is where we load the larger assembly, and this is doing the rotations. And it's clear that the GPU memory is not decreased enough at all. So we still have enough frame buffer memory, and we still have enough GPU utilization available. So this is a good target. This type of workload is a good target for possibly 4 users per GPU or 8 users per GPU, or even higher density. So this is roughly the same operations, but with the K600. Again, this is a sketching operations. You can see the overall GPU utilization is a little bit higher. And then this is where the large assembly is loaded. And you can see that the GPU is stressed a little bit more than the K5000. So that's precisely looking at applications to see how they actually use the CPU, GPU, memory, and frame buffer. Now, some customers want to use benchmarks such as SpecViewPerf, and this is an example of the same. If you run SpecViewPerf the whole run and collect the same metrics, this is what it looks like compared to that. So this is what users actually do. And this is what IT people try to do to simulate user activity. And this is not a benchmark that you can use in VDI to simulate multiple users for acceptance testing, because you can see the GPU utilization is always going to 100%. And you can see that the CPU it's pretty close to being 100% or more throughout, and the memory use is all over. So if you have one takeaway from today, or from this talk, is to understand that to understand sizing, you need to capture metrics, work with users, and look at their workflow. And if possible, record a video to go with your log to understand where in the actions those peaks and valleys lie. So you can design a solution where the users are happy and the server is sized correctly. Okay, so finally, benchmarks, they push the GPU to the limit. Actual applications have more spiky usage of CPU and GPU. And it's this place we can allow multiple machines to use the same GPU. That's how vGPU works. We're using the excess GPU resource at that moment in time to spread the GPU use across multiple virtual machines. あと何分ですか? Last 1 minute. Okay. So these examples were measuring on a workstation or VDGA or GPU pass-through. Now, I only have 1 minute, so I have to go fast. So if you want to monitor vGPU at the hypervisor on both Citrix, Zen Server, and also VMware's ESXi, if you have a GPU installed in our driver, you can use this command. Is anyone making a note? No? He took a picture. Kashikoi. In the white paper, I'll have all these sort of commands and stuff like that. So this will allow you to capture the overall host GPU metrics to a CSV file, and recommended setting is if you want to capture it at 5-second intervals and run for an hour and then automatically roll over the log, you can use the timeout command with the number of seconds and make a nice bash script, or you can do a cron job and automatically capture all these metrics to review later. Okay, did you get that? Hi. Hi, hayaku shashin totte. Got it? Okay. Okay, there's 2 more slides, and these are also important. Here's a command. You might want to take a picture of that one too. This is a command that took me an hour or so to figure out. From a command line, you can call this command, and every 5 seconds, it'll tell you what the frame rate that HDX 3D Pro is delivering. And that's important to understand how your settings, the policy settings, are impacting the frames per second that are actually delivered. Now, PCIOP has WMI counters available in Perfmon. And here you can see I have this blue line here is the frames per second that are actually being sent. So this is set to try to deliver 60 frames per second of video while I was operating with this model. And at some point you can see the frames per second drop down significantly. So this is very easy to use compared to the HDX 3D Pro. And that's it. If there's no questions, if you want to see a demo, we have what, 5 seconds? Or I could show video again. Any questions, or just I'll launch a virtual machine here. It's on my display. Let me put it on that display. Here we go. As you can see, this is our new Tesla M60 in pass-through. And I can launch CATIA. Let me see if I can make it full screen on here so I can. Okay, well, one of the nice things about VDI with our GPUs is you can have multiple displays. So I have the actual desktop here, and I'm just going to slide CATIA to the other display here. There we go. And then I'm going to launch Perfmon. So I'm going to set a counter before moving it, because otherwise I'll have to do it like that. If anyone has a question, you can ask me a question while I'm doing this.
I have a question.
Yes, sir.
So, in order for you to make...
Please wait for the microphone.
All right, we can do that. Okay, so in order for you to do proper benchmarking across different platforms, do you have any ideas for a good way to record the user movement patterns, and so that you can actually get like an actual user recording, so to speak, that you can replay on several virtual machines at the same time, to actually not just, to really do a proper simulation of actual user application usage?
So the question is, now it was in English, so I don't have to repeat it. I do not have a recommendation for ways to simulate users' actions or interactions. There are several tools that can be used, but the best way to evaluate is to have actual users performing operations, because there's a difference between human time operations and machine time or script-based time operations. Depending on the scripting method to simulate user actions, there can be CPU overhead while it's waiting, depending on how the software has been coded. So the answer is no, I do not have a suggestion. What I do recommend is, when possible, to use video capture of the users and capture the metrics at the same time, so you can do an analysis and hopefully replicate any performance issues that are encountered to find a bottleneck.
Thank you.
Thank you, Jonas. Any other questions? Sorry, I'm trying to set this counter, but it's not coming up, so.
May I ask a question?
Yes, sir.
I'm a little bit confusing about how should I understand the graph of Perfmon. So, I mean, is that the application demand for the resource, or can I understand the graph as the resource is actually given by the hypervisor, or the physical GPU, physical resource?
Okay, so that's a good point, because Perfmon is, the way I've showed these graphs and the data I've captured, I'm capturing total system or total virtual machine or total workstation metrics. So if there's other processes running that could impact the performance metrics. So in actuality, if you look at the GPU utilization, that it was basically 10 to 15%. And part of that is because I was capturing the video using our Grid SDK and using the NVEnc hardware encoder. And every time we're accessing the frame buffer, it's showing up as a spike in utilization. So that shows that the overall GPU utilization is higher than it actually is if I was not capturing video. So if you wanted to capture pure application CPU utilization, you could actually go, instead of saying overall processor, you could go to the actual process and select the process name, and then you can collect the actual GPU or CPU metrics for that application. You cannot do application-specific GPU metrics, such as utilization or memory. Those are currently system-wide only. So this is running on Wi-Fi through VPN through an old dial-up modem. Ooh, this is slow. So if you looked at this and looked at the performance of this on your local LAN versus Wi-Fi through VPN through a dial-up modem, there's probably smoke signals. The performance is very different, and I have not tuned these settings to use a really low bandwidth. So this is not a very good representation of the performance that you can get due to the ability to deliver those the frames to the desktop. Mo かなり時間がオーバーになってるだけど、次のセッションはまだ始まらないでしょ。もし誰がなんか出たいとか、僕の面白くないのギャグが飽きた場合だったら出てでもいいかもしれないけど。Are you translating that to English? And then people are saying, why do I hear English? Anyway. So I'm going to try to add this counter so that way we can look to see the actual frames that are not being delivered to us. Okay, there's one person. He's tired of my jokes. I'm sorry. 申し訳ない. My wife says that all the time. Your jokes are bad. I said, I love you. Okay, so just changing the counter color, and then I'll slide it over. Okay, so here we go. Let's just do a little split screen here. So you can see, well, I can't see, let me put on my glasses. Right now, we're not doing anything. And it's achieving 60 frames per second because there's been no updates. This is, this is the PCIe delivered frames per second, or the encoded frames per second. So when I start moving this around, it's definitely not giving me 60 frames per second. Oh wait, I'm not rotating anymore, sorry. So I'll start rotating, and you can see that the frame rate has dropped dramatically. It's not because it can't render that fast. On the server, it's actually rendering quite fast. But it's only able to deliver this minimum number of frames due to the network conditions. So the users would look at this, or have looked at these sort of results and said, the GPU is slow. And that's been a challenge for NVIDIA because our GPU on the server is very fast and very efficient at rendering this stuff. So this gives you a way to analyze what's causing what appears to be a slow frames per second, because this is slow network throughput affecting the frames per second. Okay, I got Q&A. Anyone have a question? Or another question, I'm sorry. Yes, sir. Please wait for the mic.
So you showed us that the actual rendering on the server is faster, but the network is creating the slow response.
Yes.
Is that kind of effect cured by installing something in between, like a riverbed or a net scaler?
Well, it depends on, it's a very good question. So it depends on which protocol you're using. I know that for Citrix's HDX 3D Pro, they have the ability to use both internal technology, and they've also partnered with other companies to create the ability to analyze the traffic and compress the traffic to improve the throughput. But for PCIe, I think that's something that you would have to talk to Terry Dici about. Typically, these protocols are encoded for security, and if you're using a riverbed or any of those WAM optimization technologies, they get a lot of their benefit by analyzing the traffic and removing redundant information and compressing it. So when it's encoded, the ability to compress is lost. So the way to improve this frames per second would be to change the image quality and also the target frames per second. Right now I have it set to 60, which is way too high for this network. So if I reduce that to maybe 20 frames per second, I might be able to achieve an average higher frame rate.
Thank you very much.
Thank you. Does everyone like demos? No? Everyone likes free stuff, right? Okay. でも時間が終わるだけど次のセッションが始まる? Okay. So the next session I want to do a demo. No. Just going to disconnect from this virtual machine.